So I'm a bit late to this, but I thought it'd be worth talking about anyways. But basically, MIT has a hackathon of its own. It's a very renowned hackathon because, well, firstly, it's MIT, but also because students from all over the US, but also all over the world, come to MIT to take part in this hackathon and solve real world problems. And this is an incredible opportunity for any aspiring developer, and it's a great thing to have on your resume. But there's also a very interesting aspect to Hack MIT, which I want to dive into. You see, Hack MIT being such a big competition gets thousands and thousands of applications. And MIT, for various statistical reasons, is not able to have everyone that apply take part in the competition. Now, they do have a very rigorous process to evaluate, okay, which participants are the best for the contest. But there's actually another way to get into Hack MIT. And that's what I want to talk about today. So if I scroll down over here, all the way down to the FAQs, there is this little question here, which asks, is there an admissions puzzle? And if I click on this, it will just say, woof, 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 which is a bit like gibberish, but actually there is some secret behind this. And if you're very particularly interested in finding out, you can look up the Hack MIT puzzles for 2023. But basically, the other way to get admission into Hack MIT is that you solve a series of puzzles, also known as capture the flags. In that, what you're trying to do is you're trying to decode various messages, find little information hidden inside, like websites, for example, inside the source code for the website. We're essentially trying to find vulnerabilities in the software, whether it be a website or some other form of software, to find this one very hidden piece of text, which we call a flag. And so it's called capture the flag because you're trying to find that flag, which is just a normal string, but it's fancy because you had to put an effort to actually find it. And these are some very, very interesting puzzles, and they really test your understanding, like the deep, deep core understanding of how applications work, especially web applications. But also, what I'll dive into today is reverse engineering applications, actual binary executable, and trying to find out, okay, where are the issues in this binary executable and how can I exploit this to figure out that magic string. Now that might sound scary because to look at a program which is just a bunch of zeros and ones and trying to make sense of it sounds terrible and terrifying. And even if I made it so that it's assembly, it's still a bit difficult. But actually, there's a bunch of very, very powerful tools that are available to the reverse engineer, as we call it. And today I'd like to go over some of those tools which I used to solve one of the problems uh, as part of the Hack MIT admissions. Unfortunately, the puzzles are down now, but I'll show the copies which I had saved on my device. And also you might have noticed I'm running this inside of a virtual machine. And why is that? Well, there are many, many tools that work very well on Linux that are just ideal for any sort of capture the flag. So with that said, let's dive into the actual puzzle. So I've created a repository called HackVM. So let's just go in there. I'm I'm already in the repository, my bad. All right, so if I do ls, there are three files in here: puzzle1, vm, and pwnpuzzle.py. Now this is one file which I made myself, and we'll go over that later. But for now, what's really important is this, the VM and the puzzle1 files. Now the way you're supposed to run it is you just do /vm space puzzle1, and so this file is given as an input to this file, which is a virtual machine. If you really think about it, I'm running a virtual machine inside of a virtual machine, which has like Inception vibes all about it, but oh well. So when I run this program, I get this cute little beaver which is interested in the reduced instruction set computer. Now the short form of the reduced instruction set is RISC, and in particular this problem talks about RISC 5. It's, from what I understand, a type of assembly language, but it's just with fewer instructions and a lot more, and so it's low level even for an assembly language. Anyways, the program asked me to enter a passphrase. And while I don't have the site anymore because the sites have all been taken down for the puzzles, we were originally told that the flag has the following format where it starts with hack, it has some curly braces, and inside the curly braces there's a sequence of letters and numbers and underscores, and our job is to actually figure out what this entire string inside is supposed to be. So let's just try something. Let's try hack 123. And it says, sorry, login failed. Very understandable. It would be pretty tough for me to guess the string on the first try. And so I can try to run it again. I can try a different string, hack 9999 AVH, blah. Okay. And I run this, and sorry, login failed. Okay. So, maybe manually mashing in different passphrases isn't going to be the most efficient way to find an answer, but it is fun. But now let's try to figure out how we can solve this. Okay, so one thing would be that, okay, I could create something to brute force whatever's inside the curly braces. But let's just say whatever's inside is like up to even 20 characters, right? So if I say the length is like 20, and let's say there's 50 possible characters for each position, because while you can have the different letters in lowercase, you can have the different letters in uppercase, you can have the different numbers, you can have underscore. So let's say you have around 50 characters for each position, and if the length is 20, then that gives you um, uh, a very big number of possible passwords that you might have to try. And despite how fast computers are, this is quite an order of magnitudes greater than what is actually possible within our lifetimes. Unless maybe you get a quantum computer running, then maybe you could brute force faster. But the point is that this method isn't ideal, right? And so we're going to have to try to look about this in a different manner. Now, this is the point where I'd like to mention the sheer amount of tools available for these types of tasks. So one very, very powerful tool, which is actually developed by the NSA, the National Security Agency of America, and it's basically called Ghidra. So I have Ghidra downloaded on my device, and what I'm going to do is I'm going to do /Ghidra run when I'm inside the Ghidra folder, and it's going to load up this Dragon application used for reverse engineering. Now, just before I start diving into that, one thing I want to mention is that if I do cat VM, this VM file is just a bunch of binary. Like it's a lot of binary. And when I try to interpret it using cat, it gets all mushed up and ruined. So it's a binary file, and there is a way to check that, but I do not remember. Is it file? Yeah, so file, it's an ELF, so it's an executable file. I don't remember fully. But the point is that this is some form of binary file. Ghidra is a very powerful tool because what it can do is it can convert a binary file into assembly and even into C. So what we're going to do is we're going to try that out for ourselves. So we're going to create a new project inside of Ghidra, and non-shared project, I don't remember what that does. I'll save it in my downloads folder and I'll call this test 123. Hopefully that's not been used yet. And what I'll try to do is I'll try to import a few files. In fact, well, there's the VM file and there's the puzzle1 file, and if I can, I will try to import both. Okay, I'm not able to do that directly, so I'll import the puzzle1 file, and that's really going to be sufficient for what we're going to do today. But yeah, I'm going to load the puzzle1 file. It's going to import that. It's going to give me a summary, and now the file is imported. And now I'm going to double click to load it up in Ghidra and actually view the contents of my file. Now it's telling me that puzzle 1 has not been analyzed. Would you like to analyze it now? And before analyzing, it looks like a bunch of, well, you will realize what it looks like once you know what it can look like. So I'm going to get it to analyze. I'm not completely sure what most of these settings do, but I believe these are default settings. So we click on analyze, and that just fills in our window with all of these very, very helpful uh, operands and operator names. So like the binary part is here and the assembly part is here. But this is the code for our application. And in particular, this is the code for the main part of our program. Now, this is cool and all. It's at least a little bit better than what it was like before. But at this point, I'd like to bring your attention to this window on the right, this decompiled window. Basically, what it's doing is that it's decompiling this assembly language and rewriting it as C to the best of its abilities. And when we look at this code here, we see that, well, this little chunk that we see here looks a lot like the beaver that was in the actual application when we ran it. So if I were to do /vm puzzle1 again, you see that this kind of looks like this guy, right? So, okay, we're at the part of our program which we saw on the screen. I'm going to go ahead and read this. It says, remember to submit the flag, not the pass phrase on the command center, which matches up one-to-one with the actual string we see over here. So that's pretty handy. Okay, let's see what's next. It says please enter the passphrase. Then there's this gets function. So okay, before there was this puts function, and that was kind of working like a print if we compare it to what we're getting on our terminal. And then there's this gets function. So, my understanding would be that this gets function is the function which takes in the input from the user. Okay, so we try to get the input from the user and we store it inside of this variable, seemingly. And then after that, what we do, and there's a +1, which might be because, strings have a null character at the end. So maybe it's to store that extra character. I'm not completely sure. Then the next line has svarl, which takes in the length of the string, +1 again. So this was what made me initially think it was a null character. Well, actually, no, this next line made me think it was a null character because we explicitly set the last character of our string to be a null character. All right, so that's cool. And then what we do is, so we've stored the length of our string inside of svarl. Okay. And then now there's this if condition over here. And this seems kind of interesting because it has a win inside and a lose outside. So let's think about this for a second. So the first thing it does is it checks that if svarl equals 0x2f. So, well, we know svar was storing the length of our input, and 0x2f, well, that looks like a hexadecimal number. So it's, for some reason, it's checking that the length of our string is 2f characters. And I'm going to load up the text editor and we're going to write this down, right? So 2xf, and I'm going to do the conversion for you. That's 47, right? So that's 47 characters. It's trying to check if the string is 47 characters. Now, is that, and that is excluding the null character, because the null character, because since this is 0 indexed, if we're setting svar, if we're setting the character at svar to 0, then that is going to be the 48th character. So the actual string itself is 47 characters long. Okay. Then there's this memcomp function, or memcompare is what it's actually commonly called. And it's taking in my input from what it seems like and the password. And along with that, it's also taking 0x2f, which is the length of the string, and ivar2 equals 0. Now, I'm not completely sure what ivar2 is, but what seems like is happening is that If these conditions are met, we get into the win function. Now, if we think about this theoretically, and we can even check this, so if I click on win, it's supposed to print logging in user Tim Beaver printing flag. Okay, well, this is not text that I have seen before in my terminal when I ran the VM. In fact, when I type in anything after this, it just says sorry, login failed. Okay, so the win is not that. A very good question could arise that, okay, what exactly is causing this failed string to show up? And my hunch would be that, okay, it might be this lose function. And if I look at this lose function, it says, okay, sorry, login failed, which matches pretty closely to what I'm getting. All right, so going back to our main function, we see that when these conditions aren't being met, we're losing, and that's outputting that I failed. And then if these conditions are met, there's supposed to be a win condition that runs, and that's supposed to say logging in as Tim the Beaver, presenting the flag. Okay, so this might be the actual ideal solution that we want to go for. And if that is the case, then what it's trying to tell me is that, well, this length has to match, which means whatever I input needs to be 47 characters long, which means the passphrase itself is 47 characters long. And going along that, that also means that memCompare is probably checking my input against the actual password and checking if they're the same. And if they are, then it's outputting the win condition. And in that win condition, what happens is that it prints the flag. Okay, great. Ciphertext, something, something, something. Now, a very nice thing about Ghidra is that we can actually modify the assembly, this binary over here, and create our own binaries. And the way that works is that, well, currently what's happening is if the condition succeeds, then we're going into the win condition. Otherwise, we're going into the lose condition. Now, what I initially tried to do when solving this problem was I tried to force it to always go in the win condition, regardless of if I'm actually not matching the password, and just trying to force it to go into this win subroutine. Now, to be honest, that didn't give me the desired output, and you'll see that come up later as well. But basically, what happens is that the string itself, the passphrase, the flag itself is actually encrypted, and the user input is used to decrypt the passphrase. And since the encryption is done via hashing, it'll be very painful to try to reverse all of the formulas and try to figure out the original string. So my only way around this is to actually figure out what the password string is. Now, one could argue I could try to somehow pass password in, and maybe there's a way to do that, but it's not that easy, especially for me because I don't know too much about assembly. But let's dive one step deeper. So in the problem statement itself, there was a suggestion given to check out memCompare. And in particular, it was trying to highlight the fact that memCompare evaluates a string character by character. And there's this beautiful article on the issues that could come up with memCompare. And that's that you can't actually keep your passwords very secure. And that's because when memCompare runs, it reads the characters of each string and it stops when it finds something that doesn't match. Now, if you're keen, you'll notice that this means that, okay, if the failure happened early on, then your program will end earlier on. And if the failure happened much later in the string, then your program will run for slightly longer. Now, it might sound obnoxious, but that is actually one very strong way to break a password, where you just try different passwords and you figure out, okay, if it crashed at this point in time, that means that, okay, this much of the string matched, and every time I change the character, and if the duration increased a bit, that means that character is correct, and so I can move on to the next character. In a sort of visualization, you can think of it like this, where I start off with H, then I try X, that failed pretty quickly. C, that failed pretty quickly. I put in A, that blasted for slightly longer. And you might want to run this multiple times just to make sure that that influence is not because of noise and just average it out over a bunch of iterations. But there will be a slightly larger time duration. And so I can tell for sure that, okay, A was the right letter. Then I'll try B, and I'll try I, I'll try L, and then I'll try C, and then C will take slightly longer than all the other characters, and then K, and then curly brace, and then the actual rest of the string. Right, so that is one way that you could try to break it by just checking how long the program takes to run. But there's a lot more nuance to that, and you can't just time it just as this. In some cases you can, but in this particular case you can't do just that. And this is the point where my solution starts to differ from one of the intended solutions. Nothing wrong with that, just something I like to mention. And I'm not an expert at the actual solution, but I'd like to talk about the solution I implemented. And that also required diving into memcompare. But let's try to understand what's happening in memcompare. Let's try to break down this C and this assembly and try to see what we can do to mess around with it. So here there's a bunch of variables being declared and some values being stored. But let's just try to think of this as a normal function, and this seems to be where a lot of stuff is happening. So if n is not equal 0, not completely sure what that means. Pr var s1 plus n, not completely sure what that means. Do, okay, so do is for a loop. So what is going on here? L var L equals random, okay, hash random hash u var, okay. So there's hashing going on, which is the thing which I mentioned earlier. Also, one thing to note is that this function is taking in S1 and S2. And if we remember as how it was called in main, it was taking in our input and the password. So S1 was our input and S2 was our password. So let's try to track that. Okay. So what's happening is S1 gets hashed and gets stored in ustack34. All right, and then into uvar2 after being hashed again with some random value, and then uvar2 is then XORed with itself and ustack34, and then uvar3 is XORed with uvar2 to give uvar2, and then uvar2 is multiplied by this value and shifted to give uvar3, and uvar2 comes from applying a series of operations on uvar2 and this new value of uvar3 and then bit shifting it. And so there's a lot of processes that go on to actually modify the letter which was read into the new value of uvar2. And what we'll see here is that there's this comparison at the end of all those manipulations which check that, okay, does S2 equal to uvar2? Does the password match my input? And in particular, keep in mind we're talking about a specific character of the password, or at least that's what I recall. There's no very explicit way to confirm that, but we know that mem compares to check things letter by letter. So, and there's a loop going on, so it would make sense that in the first iteration it checks a different character, in the second iteration it checks a different character. Again, I don't know enough assembly to tell you exactly where the indexing is happening, but the loop really gives kind of that impression. All right, and so what it's actually doing here is, okay, if the password does not match my input, then it's outputting uvar2 minus the value at the password. If the characters don't match, it's finding the difference between the characters and returning that difference. And then after that, what it does, okay, here is our indexing, it seems, where it's setting the value of S1 to be the value at S1 plus 1 byte, and then it's setting the value of, or it's setting S2 to be S2 plus 4 bytes. All right, very interesting things, but this is just highlighting that, okay, there is some amount of indexing going on, and this goes on while pvvar is not equals to S1. Now the question is, well, what is pvvar? And it seems like it's the pointer at the end of our string, because this is just the pointer at the start of S1 plus n. And actually, n is the size of our string, which we remember taking in as 47. All right, so pvvar4 is the pointer at the end of our string, and we just keep going through our string until our pointer for the end of the string matches the pointer for our current character. All right, so this matches our understanding of it. But now the question is, okay, what do we do at this point? And before we do anything else, just one thing that I'd like to clarify is that we see that, okay, if none of this happens, then we return a 0, which means that the strings weren't different at all. So that's an interesting to keep in mind, that if the strings are equal, then you get a 0, and if they're not equal, then the return will happen somewhere here, and it will be a positive value or a negative value, but as long as it's not going to be 0, and it's not going to be 0 because these things are not equal. All right, so let's try to contextualize our situation. So basically, we have a script that goes through every character, and if any character is wrong, it outputs failed, else if all characters are right, it outputs success. Now that's not an ideal case for me because I want to get to because because I don't actually know any of the right characters. I can give you a bunch of wrong characters because I was provided a regular expression for what the string is supposed to look like, so I can make a string which is completely wrong, but it's hard for me to come up with a string that's completely right. And starting from a string which is completely wrong and slowly inching towards one which is completely right is impossible because there's no slow inching. There is no progress. The only progress is this completely right, or is this wrong in any way whatsoever? So this isn't an ideal situation, but we can try to flip this. And now when working with reverse engineering, and in particular trying to patch these binary files, we have to make sure that the changes we make are very, very small, or at least I have to, because I don't know that much assembly, as I've said. So I need to come up with some form of different way of evaluating things where the circumstances are much more easier to play around with. And this is the point where me initially experimenting with the forcing main to always going to win would come in handy, because now I have at least a bit of idea on how to slightly control the flow of the program. So now let's consider the opposite case. What if, just a hunch, what if the program did so that if any character was right, it outputs failed, else if all characters are wrong, it outputs success. Okay, and that's just a simple reversal of the statements, right? It makes you think, okay, is this handy, and why is this so much more handy than this? Well, basically, I can come up with a string which is wrong. And actually, to go from a string which is completely wrong to a string with one character correct only requires me to go through the 50 different possibilities of that specific character. So over the course of 50 executions, I can actually figure out what a value of a character is. To make this more apparent, the actual proper way we're going to do this is we're going to have a series of right brackets, and what I'll do is, okay, this string is completely wrong, and so this will always output a success, which, you might say it should output a failure, but this was just more convenient to do. And then what I'll do is, for this specific character, for any specific character, I can just start entering values. So I'll put in a 0 if that was correct. So if that character was wrong, then it will still output a success. But I'll go through the different options, 1, 2, 3, 4, 5, and let's say 8. 8 was the perfect answer. In fact, in the entire string, maybe it was hack ABC 8 ABC 8 ABC, and then so on up to 47 characters. If that was the actual string, then this 8 would mean that one of the characters is correct. And what that would do is that would cause the program to fail. All right? Which means that if I just go to the various options for one specific character, I just have to look for when that program fails, and that tells me that, oh, the actual character behind this was an 8. And then what I'll do now is I'll replace this with the right bracket again, and now I'll start going through the different options for this character, and eventually I'll even hit the correct character for this, and then that way I'll receive a fail and I'll know to move on. And that's all fine and great, but how do we actually get that to work? And it's actually not that bad as you think it might be. So the first thing is that, okay, so this if condition which is returning the fail condition whenever our character is incorrect, what if we made it so that whenever our character was correct, it returned the fail condition? So that shouldn't be that difficult, right? It's just this not equals has to become an equals to. Now, I still can't speak binary, but Ghidra is very powerful because when I press Control, Shift, and G, it enters me into edit mode. And when you try to run it, you might be prompted to, allow it to actually do it. But if you just do that, now what I can do is I can rewrite this instruction, and I can rewrite this in assembly. Now RISC-V has some searchable syntax, so you can look it up and you can figure it out, but it's not that bad if you have some exposure to assembly language. So this statement means branch if not equal. I want to branch if equal. I want to flip the condition. So I'll just do BE, but actually it's not just BE, it's BEQ as the suggestion tells me. So I'll do BEQ, all right, and it's telling me that the binary code that I should have for BEQ is 63OCF700. All right, so that is great. I do that, and if I look here, my C code has an double equals to now. So that is progress. That is awesome. But actually, at this point, there's a very, very minor issue which we might as well deal with right now. Is that okay? If the characters are the same, what it's doing is that it's returning the difference between the characters. But that difference is going to be 0. Now, the reason that's a problem is because 0 is actually the winning condition, not the losing condition. So we need a way to get this return statement to give me anything other than a 0. And so to do that, I'll similarly try to edit the return statement, but actually it's not the return statement itself. The return is, I believe, this thing. Yeah, so this is one return statement. But the actual thing I want to edit is this subtract. And the way I knew it's this subtracts because when I hover over this, there's these instructions which are highlighted, and this is the one which says subtract. So, okay, I have to edit this subtraction, and I have to get it so that, okay, it's not subtracting these equal values. And what was most convenient for me was just, okay, subtract the 0 value. And they give you the 0 value, so that's pretty handy. And I just put that in, and that is actually it. Now it will subtract. It tries to subtract with 0, and if I look at the C code, well, subtracting it from 0 does nothing, so it actually simplifies it and just does nothing. Okay, that's great. Also, if you're confused why the 0 is over here instead of, it being like A minus B, why is it B minus C? Like, why is the thing being subtracted the third operand instead of the second operand? And that is something that you can just look up in the RISC-V syntax. Not very, it's just a very particular detail. Don't worry too much about it. It doesn't affect the logic. It's just this is how it has to be written. But that actually solves a problem. And now this new binary file is one that will actually work according to my needs. So what I'm going to do is I'm going to output this file by pressing O, and I want to make this keep the file format that the original file had so that I can run it inside the VM, and I'll save it inside this folder, and in fact I'll call this puzzle1 crack, okay, because we've cracked the file. And I'm going to save this or export this, and it gives me a summary, which I don't know what this means. It's telling me that the processor is X5. That's kind of cool. All right, so that file is apparently outputted. So now I'm going to go into my terminal, and I'm going to try to do ls, and I'm going to close this Firefox because it's just distracting. But yeah, if I do ls, I see there's a puzzle1 crack file. So what I'll try to do is do vm puzzle1 crack, okay, sorry, /vm puzzle1 crack, and here it asks me to submit a flag. All right, so let me enter a flag ABC, but I'm going to be honest, this isn't actually going to work the way we want it to. So it says login failed, but these characters, actually technically one of them is correct because the C is in the correct spot. But even if I did like this, it's going to tell me login failed, but these characters aren't right, so it should have said login successful. And that's because, well, I actually need 47 characters of right brackets. I need the length to match exactly. So what I'll do is, okay, it's telling me, oh, this is, okay, this is, wait, what? 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 Okay, I'm a genius. This is, I mean, this was one off, but it was almost 47 characters exactly, so that is actually wild. And now, if I try to run this, do shift insert, I enter this right bracket string, it tries to log me in as the user, it prints this flag, and you'll see that it's messed up, which goes back to that fact that it actually needs to decrypt the flag and it needs my user input. Now, since my user input doesn't match the actual password, so the decryption itself is also very messed up. And that's good to know, but actually the main point is that, okay, if I get the whole string wrong, it does that. What if I get one letter right? So I know the first letter is an H, so let me try to get the beginning H, right? And so if I do paste and I do this, it says login failed. Very interesting. All right, so what if I try that again, but instead of doing the first character, I know the last character is a closing brace, so I can do that as well. In fact, why even stick to first and last? Let's just go for a random central character. So I knew this beginning string is hack, so the third letter is C. So if I try to put that in, it says login failed. Okay, that is great. And just to be sure, let me just put in the original everything wrong string and see that, okay, things are, yep, they're working as intended. So great. So theoretically what I can do now is, okay, I know the first four characters. In fact, I know the first five characters because that's hack. So I can just replace these with 1, 2, 3, 4, 5. And then now I can try to bash through the value of this character. And just to save myself the difficulty of actually trying to count these, I'm just going to use this hack, curly brace, and then I try a 0 here, for example. And so if I try this, and it says logged in, so that means, okay, the 0 is not actually what is supposed to be there. If I type in an I instead, and call me Houdini, but magic's about to happen, because when I type in an I, it says login failed, because I is actually the correct letter for that entry. And in this way we can sort of bash through each of these characters and figure out each one, because now we've already constructed the final string to be hack I. And now at this point, we could technically do it manually, but there are various tools to do this way faster. And in fact, the one I'm going to use is called pwntools, which is a library for Python, which allows you to just work with the terminal and just send input through terminal, read from the terminal. And in particular, this is my pwn puzzle script, which I'm going to go through. So we import pwn, and what I do is I create a list of allowed characters, which is basically all the ASCII letters, lowercase and uppercase, the different numbers, the curly braces, and also the underscore. That's also important. And then I just have really one function and one main. And what main does is, okay, with this context.log level equals error, basically what this does is that when I'm running the program over and over, when I'm running the VM puzzle 1 crack over and over, it doesn't just spam my terminal with useless information. So that's what the log level is for, just to make sure that it's not filled up with random stuff. I create a string of right brackets just by doing s equals right bracket times 47. I construct an answer. What I do is that for each position, for each of the 47 positions, I go through each of the possible allowed characters and I construct a guess, which is a bunch of right brackets, followed by the guess character, followed by a bunch of right brackets, and I just try to run the program. And if the program runs and it's successful, it's supposed to print it. Otherwise, it just moves on to the next character. It just does that until one of the characters matches, and it just adds that at the end of answer, just to build up that string. And if you look at run program, the way run program works is that it makes use of pwntools to create a process, and the process takes in ./vm as the code file and puzzle1 as its argument. So it's calling it just how I would call it. And we go through the first 9 lines of the output. The reason we do that is because a lot of this is not really relevant. This is kind of useless. Then what we do is we send through our guess. So basically all of these lines get output, and now my program sends in the guess. Let's say it sends out hack blah 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 blah. All right, and it's failed because the string was too short, but yeah, it will send that response. It will send that line. It will look at the response, and if the response says, well, if the response says failed, what failed actually means, barring this condition when the length is wrong, what failed actually means is that the character is correct. And so if the statement ended with failed, I'll say, okay, yes, let's go. The string is correct. Let's move. The character is correct. Let's move on to the next character. Otherwise, it will return a false because, the statement didn't say failed. So that means it succeeded. But succeeding is actually a bad thing in our case. And so what this was just doing is it is bashing every single character and just one by one figuring out each character. And last but not least, we get to watch this in action. What did I change? I did not change much. Wait, Control Shift Z. Okay, all right. So did not change much, but now if I run puzzle.py, in fact, there's one more change that has to be made. The file I'm taking is supposed to be puzzle1 crack. I'm sorry if that confused you when I was going over it earlier, but yeah, that's the name of the new file. Okay. And what we'll do is we'll run Python 3 and we'll run puzzle.py, and then everything else should just work. And so when we do this, it starts decrypting, it starts bashing through each character. It figures out the 0th character is H, then A, then C, then K, then curly bracket, then I, and then it goes on and on and on. It tries each character and one by one works them all out. And once it's done all 47 characters, it says 46 because 0 index, but once it does all 47 characters, it outputs the full string by joining all of these together, which is hack instruction sets want to be free and a bunch of random numbers. So apparently this is our passphrase. And that leaves us with one final step now that we have our actual passphrase. And that is that, well, we have to get the flag, because this isn't the flag. We're supposed to get the flag if we provide the right string, but we can't provide it to our cracked one, because when we provide the right string, we provide anything right to our cracked one, that just messes up. So we will provide it to puzzle1. We'll run the virtual machine with puzzle1, provide the hack instruction sets want to be free, and voila. You logged in as user Tim the Beaver, and we've received the flag, which for once actually has proper letters and numbers instead of a bunch of question marks. And that is the HackVM puzzle for HackMIT 2023. It's definitely a lot of new things, but the overall concept of the puzzle, the solution, the complexity of the solution isn't that great. It's just that there's a lot of new things to be exposed to, which was actually one of the reasons I wanted to make this video, because there's a lot of stuff which I learned in the process. There's a lot of things, new technology I was exposed to, and I just wanted to share that. With that said and done, thank you for listening to my rant, and well, I shall do my favorite thing to do on any Linux machine, virtual or non-virtual. Actually, I don't think I've ever tried this in a virtual machine, but thank you guys, and goodbye.
So should we move on to the
Someone
next
asked,
one or same?
someone asked if there were any unintended solutions to this puzzle. I think a couple of people shared like solutions where they like patched the mem compare function.
Yeah, I think so. A couple solutions that I know, someone patched. I don't remember the patching solution. I remember someone did do a patch. So if you actually go into the Slack and check, I remember someone left a solution like that. I know one solution oh, sorry, go ahead.
Oh, I guess like I was looking at the solution, but I think they like in the comparison, they like returned immediately as soon as one character matched so that they could see whether a string has at least one common character with the original password.
Wait.
No one.
I'm not exactly sure what they're doing there. I probably have to read through the Slack post, but I don't want to open it now just in case there's something. I don't want to switch off my screen.